Okay, so Earth's the only place we know that's got life. It's certainly the only place that we can live as humans. It's really, really valuable. I mean, we know of about 4,500 other planets on in around different stars, but as far as we know, this is the only planet with life. And what we're going to first talk, we're going to talk about some constellations. So constellations are patterns in the sky, and every culture has their own constellations, but we're mostly going to talk about the Greek constellations because they're the ones we talk about in the West. And this constellation is called Ursa Major, and you might notice it as the Plough. So these stars here, they form the Plough or the Big Dipper. Okay, and we've just had a pop-up, which has just caused me loads of problems. Hold on. So this star here, that's called Miser. Okay, and if you looked at it and you got really, really good eyesight, which I definitely haven't got, you won't see one star. You in fact see two stars because Alcor's got a companion called Miser's got a companion called Alcor. If you look through it with a small telescope or a pair of binoculars, you won't see two stars. You'll see four stars. And in fact, if you've got a really, really big telescope like you get out in Hawaii or in Chile, you actually find that it isn't four stars, it's six stars going all around each other. So if you imagine you lived on a planet that was going around Mizar, you wouldn't have one sun, you would have six. And about half the stars in the sky have more than one star. So these two stars here, they're called the pointers. And they're two very, very important stars. Hold on. I've lost my mouse. They're called the pointers. So these two stars here, and they point up to up this way, and they point to a very important star and another constellation called Ursa Minor. So Ursa Minor is the little bear, and this star here is a very, very important star for us. It's Polaris, or the North Star. So Polaris sits right above the North Celestial Pole. It's completely coincidental, by the way. In 40,000 years, a completely different star will be sitting over the North Celestial Pole, and it's the only star that doesn't move during the night. So it stays completely fixed in place. It does wobble a very, very, very small amount, but you didn't really notice it. Now, a lot of people think that the North Star is the first star to come out at night, and that's just not true. In fact, actually, the most common star that you see first at night will be the planet Venus, which obviously isn't a star. It's also not the brightest star. The brightest star actually is the sun. The next brightest star in the sky is the star Sirius, which we won't be talking about, but you can see Sirius at the moment. It's in the constellation of the Dog, Canis Major. Okay, so we're now going to go to another constellation, which is very, very near Ursa Major and Ursa Minor, and that's Cassieopeia. And this looks like a really good big W in the sky as well. Obviously, someone trying to advertise McDonald's, maybe. No, obviously not. And that's supposed to be a queen upon a throne. Okay, and Cassieopeia sits in the Milky Way. There's some really, really good objects in Cassieopeia. If you've got a big telescope, it's a good place to look. So we're going to move away, and we're going to look for a very important set of three constellations. This is the Summer Triangle. So the Summer Triangle of three stars, three constellations that you'd easily be able to see tonight if it's clear. And those three constellations are Lyra the Harp, Cygnus the Swan, and Aquila the Eagle. And each one of these constellations each has one very, very bright star, and they form a triangle in the night sky, a very prominent triangle in the summer. So in Lyra, this star is Vega. It's actually one of my favorite stars, Vega. We have Deneb in Cygnus, and we have Altair in Aquila. And all these stars look the same brightness. If you look through your eye, they look pretty much brighter. Actually, the brightest of them all is actually Vega, but only just. Now, stars come in all different sizes and all different brightnesses, and they're all different distances. So we just want to explain how this works. So we have we've got Vega here, and we're going to be talking with light years. Actually, as an astronomer, I don't normally use light years. I use a different unit called a parsec, which is a bit further than a light year. So most astrophysicists like me, we tend to use parsecs. But when we're talking to the public, we tend to use light years because that's what they use in science fiction. So a light year is about 9.4 trillion kilometers. I normally round it up to the nearest 10, so about 10 trillion kilometers. So Vega's 25 light years away, and that's really, really close for a star, actually. Altair is just a little bit closer. It's 17 light years, but it's actually slightly fainter than Vega anyway. So it doesn't seem quite as bright in the night sky. But Deneb is a completely different kettle of fish. It's a completely different type of star. Deneb is 2,500 light years away, in fact, more than that. And Deneb is what we call a supergiant. So Deneb is 300,000 times more luminous than the sun. So if you were on a planet going around Deneb, which was had the same orbit of Earth. So the Earth is about 150 million kilometers away from the sun. We're a little bit further away in the summer, a little bit closer in the winter. Not very much, doesn't make any difference really. If you're around a planet around that star, the Deneb would look 300,000 times brighter, which would get you a really good tan pretty quickly, I'd imagine. So we basically have two kinds of stars in the night sky. We have stars that are about similar to the sun or a little bit fainter, and they tend to be quite close. And then we have these supergiant stars like Deneb. They're much more luminous. They're much, much further away. And in fact, actually, of the 400 billion stars in the Milky Way, only about 50,000 of them are as bright as Deneb. Okay, so we're now going to go, we're going to look at a really interesting object in the constellation. Shall we get it? In the constellation of Lyra. And this is an object called a Planetary Nebula. Okay, so it's this beautiful ring. This is a picture taken by the Hubble Space Telescope. And Planetary Nebula are very, very rare. There's not actually many of them in the Milky Way. There's only about 2,500 of them. And they're made when a star like the sun comes right to the end of its life. It swells up into a red giant and it expels its outer layers of atmosphere. That goes into space. And this is the outer layers of the sun's or a star's atmosphere that's been pushed out into space. It forms this beautiful ring. And inside, if you can just see it where my cursor is, that's what's left of that star. And that's a white dwarf, and the sun will eventually turn into a white dwarf. Don't worry, it's going to take at least 5 billion years before the sun turns into a white dwarf. So you're going to have to be hanging around for quite a while before that happens. But white dwarfs are very, very dense and very, very hot. So the surface of that star is a temperature of about 50,000 degrees, which is much hotter than the surface of the sun, and it's also very dense. So if you've got a sugar cube out of a piece of sugar, a piece of that star about the same size as the sugar cube, so a cubic centimeter, and you put it on the floor, you wouldn't be able to pick it up because it would weigh over 1,000 tons. Okay, so we're now going to move to another summer constellation, and this is actually two constellations joined together. We have Pegasus, which is the flying horse, which is this bit over here, and we have Andromeda, which is the princess. And in fact, the princess is being rescued by the sea monster Certus by Pegasus. She's grabbing hold of Pegasus and being pulled away. Now, if you've got very, very good eyesight, you go out tonight and you look towards Andromeda and Pegasus, you might just see a very, very faint misty patch, particularly if you go somewhere very dark. If you're anywhere with any street lighting, you won't be able to see this. And this is the furthest thing you can see with your naked eye, and it's also the largest structure you can see with your naked eye. And if you look through a telescope, it would look something like this. It's the Andromeda Galaxy. So the Andromeda Galaxy is not the closest galaxy to the Milky Way. I know a lot of people think it's the closest galaxy to the Milky Way. It really isn't. There are 27 other galaxies that are closer to the Milky Way than Andromeda. It's the closest large galaxy, so it's the closest galaxy like our own galaxy. It's a little bit bigger. It has about 1 trillion stars in it, and it's actually gradually coming towards the Milky Way. In about 4.5, 5 billion years' time, the Milky Way and the Andromeda Galaxy will merge, and they'll form another big galaxy. They'll do this big ballerina, and we think now that at that point the sun will be ejected into space, and it will actually leave the Milky Way because of all the gravitational interaction. But the Milky Way is really, really amazing. It's sorry, not Milky Way. The Milky Way is amazing as well. The Andromeda Galaxy is really amazing. It's 2.5 million light years away. So if there was a creature in the Milky Way galaxy, in the Andromeda Galaxy, and they were looking at the Milky Way and they could see humans on Earth, they wouldn't actually see any humans. Humans only appeared about 300,000 years ago. They'd see our very, very distant ancestors. Okay, so you can quite easily see that with the Milky Way. And I know someone just said it is cool. I think it's really, really cool as well. I like that. It's one of my favorite objects in the night sky. So we're now going to start moving to some winter objects, just to give you some idea. So this is the constellation of Taurus. Down here, we've got a constellation of Orion. They're very, very prominent winter constellations. You could see them at the moment if you stay up really late. Okay, so Taurus is the bull. You can see this is the horns of the bull. And just up here is what we call the Pleiades or the Seven Sisters. It also has a couple of other names. It's also called Subaru by the Koreans and the Japanese, and that's where the car company name comes from. I call it M45. So there's a catalogue of interesting objects called the Messier catalogue. We tend to call things lots of catalogue numbers as astronomers. So let's take a close look at it. Now, some of you, particularly if you're young and you've got really good eyesight, you will not see a faint misty patch. You'll see some stars. You should normally be able to see 6 stars with your eye. I can't actually see any stars myself. I just see a faint misty patch. About half of people just see a faint misty patch. But through a telescope, it's pretty amazing. So we're just going to zoom in and have a look at the Pleiades. And this is what it looks like through a telescope. It's pretty amazing. So this is a group of stars. They're very, very young. They're only about 400 million years old. And I know I'm very blasé with very, very big numbers. So astronomers were really, really used to really big numbers. We do it every day. We just get really, really used to them. But if you think that the Earth's about 4.5 billion years old, 400 million years isn't very long at all. So once upon a time, the sun would have been in a cluster of stars like this. There's about 400 or 500 stars in the Pleiades, and they're a co-moving group. So they're all born together and they're all moving through space together at the moment. And like families, eventually they break up. So eventually, if you live with your mum and dads, you're going to eventually go off and start families of your own. You'll leave home. And that's what happened with stars. So we think in about another 100 million years, the Pleiades will start breaking up and they'll start forming their own. They'll go their own way, pretty much like the sun did. So the sun was once in a cluster like this, and long ago it went its own way. And we've only just recently actually started to find some other stars that might have been in the same cluster. So the Pleiades are absolutely fantastic, really easy to go. There's a bit of a mystery with the Pleiades because with the naked eye you can only ever see 6 of them. You can't see 7, and we don't know why most cultures think there were 7. They're pretty much always called the 7 sisters by pretty much every single culture. We think at some time one of them is actually dimmed. We don't know which one. We don't know how it's happened, but it's a bit of a mystery. So that's the Pleiades for you. Okay, so now we're going to move away from the Pleiades. Okay, and we're going to go back to Taurus, and we're going to look at an object just at the end of the bull's horn. So this is a very, very famous object. It's another Messier object. It's another one. This is M1, so it's the first object in the Messier list, and it's called the Crab Nebula because apparently it looks like a crab. I don't think it ever looks like a crab. Okay, and this is what it looks like through a reasonably sized telescope. Even through a small telescope, you can see some kind of structure in it. And this is the remains of a star that exploded. It went supernova in 1054, so nearly 1,000 years ago. And it was so bright that for 3 days, for 3 months, it actually cast shadows at night. So you could see where you were going. From an exploding star. Now, only very, very large stars that explode, they have to be 8 times the mass of the sun or bigger. This one particularly exploded and it left behind what's called a pulsar. So right in the middle of here, you can't see it, is a very, very small star spinning very, very fast, and it's very, very, very dense. So if you've got a piece of that neutron star, that pulsar, the size of a sugar cube, and you put it on the ground, you wouldn't be able to pick it up because it would weigh about 1 million tons. So it's incredibly dense. And in fact, this object was discovered by a famous British astronomer. Her name's Jocelyn Burnell, and she was actually a student when she discovered it. And when they first discovered it, they thought it might be aliens. So it gives off radio signals. So we have special telescopes that detect radio waves, and that's how we can detect these objects, because obviously it's deep inside this nebula. And eventually this material that's been thrown out into space, that will go on to form new stars and planets, and maybe, you never know, aliens. So that's a really, really nice object in space. So we're now going to turn to the constellation of Orion. So this is a very, very famous winter constellation. It's got 2 very, very bright stars in it. So up here, we've got the very famous red star called Betelgeuse, or Betelgeuse, depending on how you want to pronounce it. Now, Betelgeuse at the moment has been doing some really weird stuff. Okay, so it's a red giant. It's right at the end of its life. It's going to go supernova soon. And when I say soon, maybe in about 100,000, maybe 1 million years. So don't hold your breath. And it started to get a lot dimmer, a lot dimmer. In fact, it nearly halved in brightness. And for quite a while, we were quite excited because we thought it might be about to go supernova. So we got really, really excited, and then we realized actually just what's happened is it had a lot of sunspots. So it wasn't going to go supernova. It's just going through what we call a phase change. So it was a bit disappointing because we thought it was going to get very, very exciting, but nothing happened. Down here on the corner is Rigel. Rigel is a blue supergiant, and it's a star right at the beginning of its life. So it's left its nebula, it's left the place it was born, and it's just shining on its own. Okay, and in about 10 million years, it will start to turn into a star like Betelgeuse, or maybe a bit longer than that. Okay, so you might see down here where my little cross is, there's this faint misty patch, and that's the Orion Nebula. So we're just going to zoom into that. It's got a Messier number, it's called M42, and we just have a look at that. And through a telescope, that's absolutely fantastic object. In here are a couple of very, very large stars. In fact, 3 very, very large stars, supergiant stars that have just been born. They've just been turned on. They're producing an incredible amount of light, and they're illuminating this cloud of gas. And inside here, there are new stars being born. And over time, these stars will blow this cloud of gas away, and we'll end up with a cluster of stars very much like the Pleiades, actually quite a lot bigger than the Pleiades. And this is right at the tip of one of those spiral arms. So right at the beginning, when we saw the Milky Way, this sits right at the tip of one of those spiral arms. Okay, and it's the spiral arm the sun is in. So the Orion Nebula is pretty amazing. So you've probably heard of the Zodiac. So the Zodiac are 13 constellations. We're going to stop that. So there's it's 13 constellations. Okay, we're just going to go through it. Here's the zodiacal constellations, 13 of them, and this line here is called the ecliptic. And the ecliptic is what we call the plane of the solar system. So the solar system is really flat. All the planets go around the sun sort of lined up. Okay, so it's like a bit like a record. So they all travel along the edge of the all on the record. And this line, is, as I said, is the ecliptic. So this is where you find the constellations. And there are 13 zodiac constellations. Okay, so we've got Libra, the scales. We've got Ophiuchus, the snake bear, we've got Sagittarius, we've got Capricorn, Aquarius, we've got Pisces the fish, Aries the ram. Yes, that's really supposed to be a sheep. I have no idea how anybody thinks that's a sheep. We've got Taurus the bull, Gemini, Cancer the crab, Leo the lion, which is one of the few ones that actually looks like it should do. It's not like, yeah, we're going to be talking about asteroids in a little while. Virgo the princess. Okay, so we're going to leave that and we're going to go to quite an amazing place I'm going to show you. Okay. So this is the International Space Station. So we're now above the Earth. So the International Space Station is about 400 kilometers up. It goes at 22,000 miles an hour. It circles the Earth every 90 minutes. So they get daytime and sunset every 45 minutes. Has a crew of 6. So at the moment, somewhere up there are 6 people in space. They live a normal 24-hour cycle day, by the way. They use GMT, just like we do in Britain. Okay, the panels are solar panels. So actually, there are 2 sets of panels. So it is solar powered. So these panels here and here and here, they're the solar panels that power the International Space Station. These here are cooling panels to help them cool off, because actually space is actually quite hot around the Earth as well. So it's very, very difficult to lose heat. These green objects here, okay, they're the 2 Soyuz capsules that are always mounted onto the International Space Station. And they have 2 jobs. One of the jobs is that they basically work in lifeboats. So if anything goes wrong, they would run into the Soyuz capsules and they'd leave the International Space Station. They also act as little tugs. Every so often they have to just move the International Space Station. That's because it gradually is actually falling, it's getting lower, but occasionally they have to just lift it up, and sometimes they have to move it to avoid incoming space debris. Okay, so we're moving away from the International Space Station now. And we're going to Earth, my favorite planet, because I live here. And some of you can see this black dot on the surface of the Earth here, and that is the shadow of the moon. And if you were living where that dot is right now, so it's now in Africa, you would see, in this case, what's called an annular eclipse. Okay, so an annular eclipse is basically like a total eclipse of the sun, but the moon's not just quite big enough to block out all the sunlight, and you get this ring of fire go around the sun. And that happened on the 21st of January, 21st of June this year, and we're just seeing it disappear now. So basically the eclipse is beginning to end, and you can see that we've got the rest of the Earth. We're just coming over to South America. I really, really like the Earth. Yeah, it's absolutely tiny. So you don't, but actually the moon is about the size of Australia. So we're going to go and have a look at the moon in a minute. But the moon's pretty amazing. Okay. Well, okay. I've got a slight technical problem. I'm just going to try to. Here we go. So we're gonna head to the moon. Here we go. So surprisingly, the moon is a moon. One of the things people do space are really, really bad at is giving things names. Okay, so the moon is a moon. It's about the same size as Australia. Okay, so actually for a moon, it's pretty big. It's one of the biggest moons in the solar system. Okay, now some grown-ups think there's a dark side of the moon. That's complete nonsense. The moon has day and night just like the Earth, but the moon is what's called tidally locked. So we only ever see one side of the moon from the Earth. That is completely normal. Okay, absolutely normal. Most moons in the solar system are tidally locked, and at the moment we're seeing the side of the moon that you don't see from the Earth. So if you look at the moon, you'll see lots of grey patches on it. They're called mare, and you only see them on the near side, and that's where really big impacts have blasted through the surface of the moon, and the lava that existed at that time is flooded out. And so the moon doesn't have any lava or anything in it at the moment. It's completely cooled down, but the moon's pretty amazing. Okay, so only a handful of people have ever seen the far side of the moon. So they would have been the Apollo astronauts who went around the moon. I think there's about 24 of them who have seen the far side of the moon. Okay, so I think we should have a quick look at the surface of the moon. This is Apollo 17. So this is what they saw when they went to the surface of the moon. So they took a little car with them, which is pretty cool. That car is still there, by the way. Yep, there's a lot of craters. So actually, if you look now, okay, you can actually see these little craters on the surface of the moon, like this one over here. They're all caused by rocks and things hitting the Earth, okay? And they basically, and the moon, and they make little craters. Yep, spaceman. Yep, that was Smith. So Smith is the only person to who's a scientist to be to the moon. So only one scientist has ever been to the moon. And yeah, it's pretty amazing. And the other guy was Brennan. He was the last person to walk on the moon. So that we haven't been to the moon since 1972. About time we went back, I think. Okay. And here we've got the lunar lander. So a pretty amazing piece of technology. Okay. So yeah, you can see their little rover there. Okay. So they took the rover on 3 of the space missions. Okay, so let's move away from the moon. And we're going to go here. So this isn't the moon, this is the planet Mercury. So the Mercury looks a lot like the moon, and a lot of people mistake it for the moon. And that's because, like the moon, it's got no atmosphere. It's actually not a lot bigger than the moon. And because it's got no atmosphere, there's no way to fill in the craters. There's no water, there's no air, there's no wind. And so craters don't get filled in. So basically, Mercury looks a lot like very, very similar to the moon. The only difference between Mercury and the moon is it has no mare. Okay. So yeah, so it's a really, really, really beautiful place to go. Actually, as it goes, as a planet-wise, Mercury's really, really boring. We've had a spacecraft orbiting Mercury for quite a while. That spacecraft's called a Messenger. So it's a European NASA mission to look at Mercury. But Mercury's actually quite dull. The next planet we're going to go to, that's a lot more interesting. Okay, so we're going to head out to Venus now. Right, so here we go. So here comes Venus. So this is Venus without any atmosphere on it. So Venus is cloudy all the time. So from Earth, you can never see the surface of Venus. So there's no point in showing you just a big white ball. So I've shown you without the atmosphere. So Venus has what's called a runaway greenhouse gas. So you guys all know about climate change, about how the Earth is getting hotter because we're burning lots of fossil fuels. And that happened to Venus very, very early in its life. In fact, Venus's atmosphere is nearly entirely made of a gas called carbon dioxide. And carbon dioxide is poisonous to humans, but also it's a really powerful greenhouse gas and it traps the heat. In fact, it's so hot on Venus, it's like wearing 90 duvets. Okay, so it never gets colder on Venus than about 450 degrees. And that's so hot, we think on the surface of Venus, there aren't lakes of water, there are lakes of liquid metal. So there are liquid lead lakes. Even worse than that, that it actually rains. And when it does rain, it doesn't rain water, it rains acid. So it would dissolve you. And something does have an atmosphere. It has an atmosphere 90 times thicker than the Earth. So of the 4 terrestrial planets, it is the thickest. Now, something you might notice that actually Venus doesn't seem to have many craters on it. And that tells us something really important. It tells us that the surface is very young. So the Earth doesn't have many craters on the surface. Okay, and that's because they get eroded, and that's because the surface changes and we have volcanoes and things. So we think that every so often Venus turns into almost one big volcano. So the whole planet begins to crack and lava from the center fills in. So Venus, really, really hot, rains acid, lakes of liquid metal, not a good place to go to holiday, is it really? Okay, so let's go to somewhere that is a little bit nicer than Venus. Okay, so let's head off. Hold on. Here we go. So this is the planet we've visited the most, obviously, besides the Earth. This is Mars. Okay. By the way, this is what's called it's a terrain map. So the blue areas are the part of Mars where it's lower than the high areas. Okay. So Mars is quite small, and it's lost most of its atmosphere. So Mars used to be very warm, and it used to be very wet. So Mars used to have oceans, lakes, rivers, and it used to be very, very much like the Earth, we think. And in fact, we've got a new group of spaceships going to Mars, including one that's been built by the Europeans. It's called the Rosalind Franklin. Rosalind Franklin is a very, very famous woman scientist. She's a British scientist. You should look her up. She's really amazing. And they're going to see if there was ever life on Mars. At the moment, we don't think there was, but we're going to try to find out. So Mars has got some really, really amazing features on it. Here it's got these volcanoes. This volcano here is the largest volcano in the solar system. It's called Olympus Mons. It's the same size as France, and it's so tall that if you walk to the top, when you get to the top, you'd be in space. This here is the Marina Valley. So this is a river valley that looks a bit like the Grand Canyon, but it's the size of the United States of America. So if you put this over America, this side would be Los Angeles and this side would be New York. So it's absolutely huge. So Mars does things really big. Okay, so it's pretty cool, Mars. Okay, and that's the Marina Valley. So we're just going to briefly go to the surface of Mars. Hold on. It is very orange. So Mars is orange because it is actually rusty, believe it or not. So this is what the surface of Mars looks like. And this is taken from a spacecraft called Opportunity. And it's just taking a panorama. And you might have seen places on Earth that look very, very similar to this. So there are places on Earth where there are lakes that are completely dried up, huge, huge lakes which have completely dried up. And it looks very, very similar to those lakes that have dried up. Now, Opportunity is solar powered, and you can see her solar panels here as they come into view. And unfortunately, those solar panels really got covered with dust. And so, unfortunately, now poor Opportunity has died. This is her sister spacecraft lander. This is a lander called Spirit. Now, very early on in Spirit's journeys, it broke a wheel. So this path that you can see here is where she's been dragging her wheel along. And she's got very, very dusty solar panels. And you can see this is a different area of Mars. It's a lot more rocky. Okay. And this is an impact crater. So this is where a big rocks hit the surface of Mars, and we thought we'd find loads of interesting rocks, and we did find lots of interesting rocks. We've currently got another rover on Mars at the moment called Curiosity. That's trundling around. Curiosity is nuclear powered. She's not solar powered, so she's been a lot more successful. The Americans are supposed to be launching a new one at the end of the month. That's also nuclear powered, and it's also a twin of Curiosity. So Mars has got two little moons. It's got two little moons. It's got Phobos and Deimos. There we go. And Phobos and Deimos aren't very big. They're only about 20 kilometers across. So they're about the size of London. And they're basically captured asteroids. So I know one of you said about the asteroid belt a little while ago. And someone has said, yes, it's got ice caps. Mars has got, you can see the Martian ice cap there. It isn't probably water. It's probably dry ice, so frozen carbon dioxide. And we think that there is some ice potentially on the surface of Mars. We're going to have a look. So now we're going to go to the biggest planet in the solar system. This is Jupiter. So Jupiter is a gas giant. So the 4 planets we've just spoken to, they're solid. But Jupiter is made of gas, basically. And we can see some of the moons here going around Jupiter. Jupiter's at the moment got 79 moons. We keep on finding new ones. It's really annoying for people who do space like me. I talk about space a lot. They keep on adding new moons. So we've got a spacecraft called Juno that's going around Jupiter at the moment. So Jupiter's really famous for its giant red spot. And its giant red spot is a hurricane. There it is. The hurricane's 3 times the size of the Earth. Typical wind speeds in the Great Red Spot, about 1,000 kilometers an hour. So to give you an idea how windy that is, if you had to go to school on Jupiter, by the time you got to school, the wind would have blown all your hair out of your head. It would have blown your eyebrows off your face, and it would have blown all your clothes off. So you'd have to go to school on Jupiter naked and bald. So this is one of the moons. This is Io. So Io is the closest moon to Jupiter. It's actually quite a big moon, and it's covered in volcanoes. In fact, Io is the most volcanically active body in the solar system. Yeah. So I always think it looks like a pizza. A friend of mine thinks it looks like a jacket potato. I'm not sure. Wonder what you think it looks like. Okay. So this is Europa. So Europa is a very big moon of Jupiter, and it's covered in these stripes. And we now understand what's going on. So Jupiter, Europa, is got all these stripes on it. Let's go back a bit so you can see the stripes a bit better. There you go. And it turns out it's covered in ice, Europa. In fact, Europa's got more water on it than all the oceans on Earth put together. And we think it might be a really good place to find life. So we're hoping to send a robot to Europa. It's going to burrow its way through the ice, even though the ice is up to 5 kilometers thick. And it's going to try to find out whether there's life in the oceans of Europa. I think that's really, really amazing. Okay. So we're going to go to my second favorite planet. And it's Saturn. It's got a ring on it, obviously. So Saturn's rings are made of a moon that have... Whoa, that's gone wrong. I've gone all right. Accidentally all gone to the beginning. Saturn's rings are made from a moon that's got too close to Saturn. And it's... Hold on, I've done it again. It's got too close to Saturn and it's been broken up. Okay. So it's made of rocks and ice. The biggest bits of it are about the same size of a double-decker bus. Most of it smaller than a grain of sand. Okay. The rings are very, very wide. They're about 100,000 kilometers wide, but they're very, very narrow. In some places, they're only 10 meters thick. And also very bright, which is a bit of a surprise. So we had a spacecraft called Cassini that did a lot of work on Saturn, and it looked at how dirty the rings are. So the older the rings are, the dirtier they get. Okay, so it's a bit like all that dust building up underneath your bed. The deeper the dust underneath your bed, the longer someone hasn't vacuumed under there. And we actually found out that that Saturn's rings are very, very young. They're only about 100 million years old, and that came as a big surprise. We thought they were going to be much, much older than that. Now, 100 million years might seem a long time for you, but considering the solar system is 4.5 billion years old, that's really, really young. And the rings aren't going to last much longer. We think they're going to last for about another 100 million years. This is the biggest moon that Saturn's got. This is Titan. Titan is the only moon in the solar system with a really thick atmosphere. And it's also got liquid on the surface, although it's really cold. So on a warm day on Titan, it might get to a balmy minus 190 degrees. So you might want a hat. Yeah, so we've actually had a lander on Titan. So Titan is the only other body in the solar system besides the only other moon in the solar system that we've had a lander on. Okay, so moving on from Saturn, we're going to go to Uranus. Okay, so Uranus, we don't really know much about Uranus. Okay, because it's a really, really long way away. We've only ever been to Uranus with one spacecraft, and that was Voyager 2, and there's no plans to go back yet. But some weird things are going on with Uranus, and Uranus isn't like Jupiter and Saturn. Jupiter and Saturn are both gas giants. They're mostly made of gas. So Uranus is very, very similar to the other planet that's out in this part of the solar system, which is Neptune. And they're sort of made of slushy. So I know you guys, you like going to the cinema and you like getting to a slushy. So what kind of flavour slushies do you guys like? Why don't you just put something in the comments so I can see what kind of flavour slushies you like? Strawberry. Yeah, that's my favourite as well. Oh, someone likes mixing them. Okay, well, I'm going to tell you, I don't think you'd like a slushy from Uranus or Neptune. So if you had a slushy from the ice of Uranus and Neptune, it would taste of fart. Is that something you'd like to try? Okay. So yeah, so Uranus and Neptune, they've got lots of moons as well. This is a really weird moon of called Miranda. So all of Uranus's moons are named after Shakespearean characters, and Miranda looks really, really odd. And for a while, we didn't know what was going on, and we think an asteroid has hit Miranda, hit it, smashed it apart, and it's gone back together, and it's all been jumbled up. So it's like, imagine that you broke one of your mum and dad's vases, and you put it back, and it's all been put back, so bits are inside out and stuff like that, and it's all jagged, and places are all in the wrong place, and that's what Miranda looks like. It's also got a really big moon called Titan. It's one of the largest moons in the solar system. I think it's about the 8th largest moon in the solar system. It looks a lot like Europa. So whether it's got water on Europa and maybe oceans underneath, we don't know, but it looks a lot like Europa. Okay, so let's head off to Neptune. So Neptune looks an awful lot like Uranus, and they're very, very similar. We don't really know an awful lot about Neptune. In fact, Neptune's is twice as far away from the sun as Uranus. So if you did a scale model of the solar system with the sun in the middle and Neptune right at the end, the planet in the middle would actually be Uranus. It's really, really odd. Okay, so now, some weird things about Neptune and Uranus. Uranus is tipped on its side, and we don't know why. And actually, Neptune is warmer than Uranus, even though it's twice as far away from the sun, and we don't know what's going on there. And there's lots of evidence that suggests at one time Neptune was where Uranus was, and Uranus was where Neptune was, and we don't know how that could have possibly happened. So it's all a big mystery. I'd like us to really go back to these two planets. I mean, as I said, the only spacecraft we've ever been to these two is a spacecraft called Voyager 2. And that was a long time ago. It's in the early 80s. And we really ought to go back. We've got a lot better technology now with spacecraft. So Neptune's got this moon. This is called Triton. So Triton's a really odd moon. So it's one of the largest moons in the solar system, and it's going around Neptune backwards. And it's one of the very few moons, well, certainly the only few large moon that goes around the planet backwards. Now, we know that most moons form like planets do around the sun. So planets form from the big gas cloud that the sun forms from. And we think that big moons like Triton should form around the gas cloud that forms around planets when they're forming. That clearly hasn't happened with Triton. And we think Triton was once where Pluto was. So it's what we call a captured dwarf planet, which is pretty exciting. So speaking of dwarf planets, we've got a very, very famous dwarf planet here. This is Pluto. By the way, Pluto never was a planet. We made a mistake. So when we found Pluto back in 1930, immediately we thought it was a bit small, but we thought it was a planet because it was the only thing it looked like. Then about in the early 2000s, we started discovering lots of things that looked like Pluto, and we realized that actually Pluto wasn't a planet. There was lots of arguments about what Pluto was. I personally don't like the term dwarf planet because it's definitely not a planet. And the reason why it's not a planet is nothing to do with its size. Okay. So we had a spacecraft a few years ago called New Horizons that went to Pluto, and this is why we've got some very, very good footage of Pluto. So Pluto's turned out to be very, very interesting. It has lots of surface features. It's quite active. It has volcanoes on Pluto. They're not hot volcanoes, by the way. They're cold volcanoes, what we call cryovolcanoes. It's got a little bit of an atmosphere as well. It's very, very, very thin. But it's a really interesting place. And when we built New Horizons, we actually built it from bits of spacecraft we had left over. So we just cobbled it together. This bit here, this is the nuclear power supply, which was a spare that we had for Cassini, which was the one we sent from Saturn. I think this antenna comes from a Galileo probe, which was a spare we had, which got sent to Jupiter. So basically, we made it out of leftover parts, and it actually had a really, really good run. It discovered loads of things. It's now looking at objects on the far edge of the solar system, way beyond Pluto. Pluto's also got 6 moons, including a very large one. This is Chiron. Chiron's got some interesting features on it we don't really understand. We think that occasionally when you get big volcanoes on Pluto, some of the stuff that the volcanoes shoot out end up on Chiron. So one side of Chiron, like here, we can't really see it very well, has a very, very similar color to Pluto. So we think that might be going on. Okay, so at the moment, there's something really amazing going on, something you've probably never seen. There is actually a comet that you can see with your naked eye. So if it's clear tonight, go out just after the sunset, look towards the sun, and you might be able to actually see this comet. It's called Neowise. Basically, it's named after the telescope that discovered it. But comets are basically big dirty snowballs, and as they get close to the sun, they begin to melt, and as they melt, they cast off this big tail, and it makes them look really, really big in the sky. A few years ago, we sent a spacecraft called Rosetta to investigate a comet called Churyumov-Gerasimenko, and yes, I did practice saying that quite a lot. So this is Churyumov-Gerasimenko. It's at the stage where it hasn't got its tail yet, it hasn't started melting. I always think it looks like a rubber duck a little bit. But we found out actually something really, really amazing that came from this mission. And it turns out that all the water on Earth, or pretty much all the water on Earth, actually came from comets. So I have a glass of comet juice here. And you probably had a shower or bath in comet juice. Now the swimming pools are open, the outdoor ones. You could go for a swim in comet juice. I think that's really, really amazing that we've discovered that it came from comets. So there's other dwarf planets as well, and probably the most important dwarf planet is not Pluto, it's this one. This is Ceres. So when Ceres was discovered on the 1st of January 1800, we actually thought it was a planet. So the same thing has happened to Ceres has happened to Pluto. We mistook it for a planet, and it turned out it wasn't. It's the only asteroid that's become a dwarf planet. So eventually we started to discover it was an asteroid, and then later on we reclassified Ceres. When we realized it was spherical, we reclassified it as a dwarf planet. This bright spot here, we're not entirely sure what it is, but we think it's some kind of ice. This is a spacecraft that's been orbiting Ceres. It's called Dawn. So Ceres is really, really interesting. It does look like a moon more than a crater. Yeah, the big crater is we don't really know what it is. It's a bit of a mystery, but we think it's full of ice, which is why it's really, really reflective. And this side of the Ceres is pointing towards the sun. So you've probably heard of the asteroid belts. So actually, there isn't just one asteroid belt. There are multiple asteroid belts. The most famous one is the one that Ceres is in, which is the one that lies between Jupiter and Mars. So there are lots of asteroids in there. Here's a few of them. Asteroids belts are not like it is on the science fiction movies like Star Wars. The average distance between an asteroid and an asteroid belt is over 1 million kilometers. So when Han Solo is flying the Millennium Falcon through an asteroid belt, he'd have to be a real rubbish pilot to hit an asteroid, okay, because they're so far apart. You know, you don't have to swerve or anything; they're real far apart. But asteroids are basically the leftover bits of a of the formation of the solar system. So you guys, like me, I like making Lego models, mostly the spacey ones, surprisingly. I've got lots of Lego models, and I've always got a bit left over after I've made the model, the bits that they put in extra that you never use. And that's basically what asteroids are. They're basically the leftover bits of the solar system that didn't ever turn up in planets. Some people talk about maybe the asteroid belt between Jupiter and Mars would form into a planet. There's no chance of that happening. In fact, nearly all of the mass, all of the stuff is actually in Ceres. So there isn't enough stuff in the asteroid belt to form a planet, to be brutally honest. There's a couple of other big asteroids. There's Vesta, which is quite a big asteroid, but they're nowhere near big enough to form another planet. Okay. So we're just going to talk about the sun. Okay, so you probably know the sun is a star. It's a perfectly normal star. The surface temperature of the sun is about 5,500 degrees, which is quite hot. But the center of the sun is 15 million degrees. Now, the sun isn't on fire. It's not burning. It's doing something called nuclear fusion. So it's taking the gas hydrogen and turning it into the gas helium. And when it does that, it loses a bit of the stuff it was made of. So the sun is actually getting about 4 million tons lighter every second. So 4 million tons of the sun is being turned into light every second. But don't worry, there's still a lot of it left. There's at least enough left for about 4 billion years. Okay. Right, so these things on here are called sunspots, and sunspots are basically bits of the sun that are slightly cooler. They're about 500 degrees cooler, and sunspots are really, really important in how the sun manages its energy. So unfortunately, the sun, as I said, isn't going to last forever. Okay, and in about 4 billion years, we're going to start getting some changes in the sun. Okay, so you don't have to worry about it. At this point, I've had a few people cry. I'm sure that's not going to happen. But yeah, so we're going to start getting some changes in the sun. Okay. Oh, sorry. It's okay. We're going to start there. We're going to get some change. So we're going to need to go back to the sun. So what's going to happen is that the sun's going to start running out of fuel, and that's going to start making it swell up. So you're going to see the sun start swelling up. So we've got the Earth here. Okay, and the sun's gradually going to get hotter. By the way, this has got nothing to do with climate change. So some people might tell you that climate change has been caused by the sun getting hotter, but that's not the case. So the sun's going to get bigger and bigger and bigger, and it's going to swell up Mercury. Mercury's going to end up in the sun, and then Venus is going to get us the sun, and the Earth's going to get really, really hot. All the oceans are going to boil, and eventually the sun will get so big that the Earth is going to be inside it, and that will be it. So I think someone says that it will be a supergiant. It won't be a supergiant. It's not big enough to be a supergiant. It just turned into a red giant. So that's actually the end of my planetarium show, pretty much. So I'm going to try to answer some of your questions while we're here. So I'm just going to stop my share. I hope you enjoyed that, and I'm going to close my software so I can see all the streams. So let's have a look. So if you ask some questions, I can answer them. Hopefully, I will do my best. So someone said about a black hole. Okay. So what's a solar flare? Okay, so solar flares are really interesting. So sunspots always come in pairs, okay? And what's called the sun's magnetic field, that comes out of one of the sunspots and goes into the other, okay? And material from the sun, which is really hot, gets stuck in there, okay? And it gets twisted up like an elastic band. And eventually that elastic band breaks and it throws material out into space. And that's called a solar flare. And sometimes they hit the Earth. And when they hit the Earth, we get what's called aurora. So I'm really, really lucky. I used to have to go to Iceland a lot. And I used to see aurora all the time. So you might see aurora down this far south in sort of London and the southeast. You might see it once in a human lifetime if you're lucky. So why is Pluto not a planet? And the reason why it's not a planet is because it hasn't cleared its orbit. So in fact, actually, sometimes Pluto is closer to the sun than Neptune. So planets have to dominate their orbit. So there's 3 rules for a planet to be a planet. It has to go around a star like the sun. It has to be in hydrostatic equilibrium, which is posh sciencey speak to make it's got to be a ball, basically. Oh, and Pluto meets both of those. And it also has to dominate its orbit. So basically nothing else can be crossing it. And that's not happening with Pluto because Neptune's in the way. Neptune's much, much bigger. And that's why Pluto's not a planet. So let's have a look. If I could pick one planet for us to move to, well, the only planet that we've absolutely got any chance to move to is Mars, unfortunately. And even then, it wouldn't be particularly nice. So you certainly wouldn't be able to go outdoors on Mars. There's hardly any atmosphere on Mars. The atmosphere that it has got is poisonous as well. And it's also really cold. Okay. And there's no water, as far as we know. So we are looking for water. So that's a good one. How are the volcanoes on Pluto cold? Well, that's because Pluto's a long way from the sun, for a start. And basically what happens is we think that the inside of Pluto might be molten. So Pluto's mostly made of ice. And basically it melts just like the center of the Earth is molten, and sometimes it shoots out. So rather than being lava volcanoes, which are like about 2,000 degrees, these volcanoes are sort of just above freezing. So it's really weird. So does Jupiter? Yeah, Jupiter has 79 moons. At least that's 79 we've found. It's probably got more than that. Saturn's got 81 moons. Is there a black hole in every galaxy? That's a really good question. Right, so there are basically 2 kinds of black hole. There are what are called stellar mass black holes, and they're called by stars when they come to their ends of their lives and they die. And there were supermassive black holes. So there's about 100 million stellar mass black holes in the Milky Way, and we think every galaxy has stellar mass black holes. Supermassive black holes are much rarer. So we only think that a galaxy will only have one supermassive black hole. Occasionally we find one with more than one, but that's merged with another galaxy. But not all galaxies have supermassive black holes, and that's a really big problem for astrophysics. Yeah, so we don't really know how you make a supermassive black hole. So it's a real we're a real puzzler like that. So yes. So I'm going to answer one more question. I'm afraid I'm going to have to go. Would we have to grow things on Mars? Inside, yes. So I've got a friend who's an astrobiologist, and she's been trying to make an artificial Mars. So she's got a lab where they've got Martian atmosphere and Martian light, and she's trying to grow things there. So far she hasn't managed to grow anything. It's really, really hard. Okay, right. I'm going to try to do one. Why are stars so heavy? Well, they actually don't weigh anything at all. So stars are, you've got to realize the difference between how heavy something is, and that's how much stuff they've got, plus what kind of gravity is pulling them down. Okay. And then there's mass, which is how much stuff you're made of. So if I put you on the moon, your mass wouldn't change. There'd still be the same amount of stuff in you. Okay. But your weight would change because there's less gravity. So I've got one last thing to answer. I can't answer the one with dark matter because that'd take a long time. But no, there's no such thing as a white hole as far as we know. Okay, so originally we thought that maybe something called a quasar were white holes, and we now know that's not true. But you have absolutely asked loads and loads of questions, so I'm wrapping up now. But thank you. You've been absolutely amazing. You've been asking some pretty amazing questions, and hopefully I'll see you in the near future.